Welcome to the unit on thermodynamics and equilibrium. In this unit, we're going to be reviewing enthalpy, which you have covered in previous courses. We're going to be introduced to the concept of entropy and then bringing the concepts of enthalpy and entropy together to evaluate free energy. So let's look quickly at the laws of thermodynamics that govern these physical properties. The first law of thermodynamics you should be very familiar with. It's the law of conservation of energy, where energy cannot be created or destroyed in a chemical reaction. The second law states that the entropy of any isolated system not in thermal equilibrium almost always increases. So the focus point of this is entropy is almost always increasing. And the third law of thermodynamics is also about entropy, and it says it approaches a constant value as we get to absolute zero. So when T is equal to 0 Kelvin, the absolute coldest temperature, then entropy is equal to zero. Or I'm sorry, the property of entropy is equal to zero. Some key concepts that I want you to keep in mind as I'm going through the material. There are some terms that I use. The official term in this unit will be spontaneous. We will be able to determine whether or not a reaction is spontaneous under normal conditions, and that's going to be governed by the free energy. However, when we are discussing both enthalpy and or entropy, we can use the terms favorable. Favorable and not favorable are not the same thing as spontaneity, but they're important in our understanding. Either the entropy or the enthalpy can favor a spontaneous reaction or not favor a spontaneous reaction, but those descriptors don't decide whether the reaction is spontaneous. These are things that will have to work together to figure out spontaneity, and we'll work through that more later in the unit. All right, so there's your introduction, and let's move on to our review of enthalpy.